And lastly, rocking the word problems. So, a go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates that there will be 20 more racers for every $1 reduction per racer in the price. How can the owner of the go-kart track maximize weekly revenue? So the first thing we have to do is figure out what's going on. Right now, there are 380 racers, each paying $35. So if nothing changes, we have 380 racers, each paying a rate of $35 per race. And so the current revenue, you're going to multiply those things together. So 35 times 380, using your handy-dandy calculator, is 13,300. If we reduce the price by $1, so 35 minus 1 is 34. There will be 20 more racers. So 380 plus 20 is 400. 400 times 34 is 13,600. So he makes $300 more, reducing it by $1. What if we reduce it by $1 twice? That would give us $33 in price, but we would increase the number of people by 20 also twice. So there'd be 420 people. $13,860. What if we reduce the price by another $1? So 35 minus $1 3 times. That'll get us $32 we're charging for all of 380 people, but 23 times for 440. Okay, so I think I figured out what's going on here. Because here we are reducing it by 1 0 times. Here we're reducing it by 1 1 time. Here we're reducing it by 1 2 times. Here we're reducing it by 1 3 times. So it seems like I have an X. Ooh. Like I have an X going 0, 1, 2, 3, where X is the number of price reductions, and Y is my revenue over here. So looking at one of these to come up with what two things I'm multiplying together to get my Y, my revenue. my y I'm getting from the 32 came from 35 minus 1 3 times. Minus 1, the number of price reductions is my x. Where the 440 came from, 380 plus 23 times. The 3 times is the number of times we reduced the price by $1. That's the super hard part. You have to take the problem, read it through thoroughly, figure out what everything is. After that, we multiply this together, everything in here times everything in there. We get our y. So that we can say our x is negative b over 2a, negative b over 2a, and so our x is 8. We substitute that back in, f of 8. We're going to plug that into our calculator, and it's going to tell us our maximum revenue is 14,580. The owner can maximize his revenue to $14,580 by lowering the price by $8. So this is the expectation, being able to come up with this formula, work the math through, and draw a conclusion. Some other fun things here from our table. Now we're into the aside part, just information that we should know from past studies but might not remember. This is our first difference. What happens when we subtract? Let's see if I can get my pen to write here, sorry. Our first difference. So we're going to take and we're going to subtract here. We're going to take and we're going to subtract here. We're going to take and we're going to subtract here. Those aren't the same, but if we take and subtract again for the second difference, we get 40, we get 40. If you did another row with 4, you would get 40 again. The second difference all matches, so we know this has to be a quadratic equation. If we couldn't come up with that formula by ourselves, what if we were on a test where we could use our graphing calculators? What if we took this information here, and instead of x and y, we put it in for list 1 and list 2? So you would have to go second stat for, you'd have to go stat to get to the lists to edit. The first thing that comes up is edit. So you hit enter for 1. You're going to put in the x values for list 1 and the y values for list 2. You're then going to go second stat plot. You have to turn stat plot 1 on. So we hit enter on number 1. We hit enter on. And then we graph. And you'll get a nice graph of these points. That's useful, but not super useful. If we go back to stats, but this time we go over to calculate. If we go down to number 5, it says quad reg, which is quadratic regression. If we hit 5 for list 1 and list 2, so we have to hit enter for list 1, enter for list 2. Then you just hit enter 3 times for frequency list, reg EQ, and calculate. And it comes out with a y equals ax squared plus bx plus c, where a equals -20, b equals 320, and c equals 13300. Our A, B, and C from up here. The r squared tells us that we have a perfect correlation here. This is the exact parabola that goes through all 3 of those points perfectly. So a little bit of statistical analysis here can also get us to that same point, but we have to be on a portion of the test that we can use our calculator on to do that. So, a cool aside there, some calculator tips. Have a great day, everybody.